Hi everyone, this is going to be a little bit longer a video. So I went ahead and brought over my neighbor's chinchilla. Chinchillas are very well known for their skills in finding zeros of polynomial functions, so it'll be very helpful. So first off, go ahead and meet Chili. This is not chili like the chili you eat. This is chili like I like to chill on the weekends. Chili, this is Chili the chinchilla, so he's nice, doesn't bite, don't worry. He can get a little agitated if he doesn't get his sleep, but he's got a good night of rest underneath his belt, so he should be very helpful in theory. All right, let's go ahead and step into finding zeros of polynomial functions. Okay, here we have the polynomial f of x equals 4x to the fifth plus 2x to the fourth minus 3x cubed plus 5x minus 6. We want to find the possible rational zeros. Just a quick refresher. Remember, rational just means something that could be written as a fraction. And zeros, these are where the graph crosses the x-axis. If we set our f of x equal to 0 here, if this was equal to 0, we'd solve for x, and those would be our zeros. Now, in finding these rational zeros, we like to use the variables p and q. Now, your p variable is always going to be your constant term. Your constant term is -6. So I can go ahead and come right down here and say that my constant variable is -6. Now your q is going to be the coefficient of your leading term. Your leading term, remember, is the term with the highest degree. Usually it's right in the front. So my leading term is 4. After you've written what your p and q is, what you want to do is list the factors of each of these. So here I have -6. My factors of -6 are going to be 1, because 1 times 6 is 6, 2, 3, and 6. All of these are numbers that multiply into 6. My factors of 4 are going to be 1, 2, and 4. I just list all the factors of each of my p and q. Okay, from there, I go ahead and what I'm going to do is I'm going to write all the possibilities. These are all my possible rational zeros of p divided by q. And it's going to be a positive or a negative p divided by q. So what that means here, oh, Chili, don't run off. We still need you. Come on back. What that means here is we take each of these factors that we found on p, so we take 1, 2, 3, and 6, and we put each of those over our q's, 1, 2, and 4. So starting here, I could put 1, this p, over the first q here. That's 1 over 1. I'll go ahead and put plus or minus 1 over 1. My next combo is going to be, I'll take this first p again, 1 over 2. Okay, let's go ahead and do 1 over 4. 1 over 4. Okay, next I finished all my 1 possibilities, so I'll go ahead and go over to 2. I do 2 over 1. 2 over 1. Then I'm going to do, come here, Chili. Then I'm going to go ahead and do 2 over 2. 2 over 2. Then I'm going to do 2 over 4. 2 over 4. Okay, then I go over to 3 and I do the same thing. So I'll do 3 over 1, 3 over 2, and 3 over 4. Back down here, I've got 3 over 1, 3 over 2, 3 over 4. And then my final one, I have a 6. I'll do 6 over 1, 6 over 2, and 6 over 4. 6 over 1, 6 over 2, and let's do 6 over 4. So again, all you're doing is taking all your possible p's divided by all your possible q's, positive and negative. So if I wanted to take this and make a list of all my possible rational zeros, so if I had this polynomial up here and I'm trying to find all my possible rational zeros of all of this, all the zeros, every single one of those zeros can be found in this list of numbers. So if I wanted to write just this whole list out, I would have plus or minus, that's a positive and a negative. We've got 1, we've got 1/2, 1/2, 1/4, 2. This 2 over 2 would be the same as 1, which we already have, so I don't need to rewrite that. So I said we had 1/4, 2, and then you just go through all of these, and of course you want to simplify, so 2/4, that would be the same as 1/2, so we don't need to rewrite that, but we would write 3 3/2 and 3/4, 3 3/2 and 3/4, and 6 6/2, and we also had 6/4, 6 6/2 is just 2, and then 6/4 would be 3/2, which we already have anyway. So all our possible rational zeros would be listed right here, and we could test these. Now it doesn't mean that they all are zeros, it just means they're possible zeros. So this is going to give us a starting point to finding what our actual zeros are. Okay, now that we know how to find our list of possible rational zeros, let's look at how we actually find the zeros. So Chili's going to go ahead and make our list of possible zeros ahead of time. So our p in this polynomial is -9. Our factors are 1, 3, and 9. Our q is 1. The coefficient is x to the 4th is just 1. So our possible rational zeros are 1 over 1, 3 over 1, and 9 over 1. And remember, you always have to do the plus or minus. So how we're going to test these polynomials here is we're going to set up a synthetic division problem. So I'm going to go and take all my coefficients from this polynomial and set up a synthetic division problem. So remember, I go ahead and put my little chart here. My coefficients are 1, 4. I don't have an x squared term here, so I need to put 0. Then I have -12 and -9. Now to test, to start trying to find my zeros, I just go through this list here, and I do synthetic division, and if I'm get no remainder of 0, then I know that is a 0. Let's go ahead and test +1 first. So I'm going to go ahead and put +1. If I do synthetic division, I'll get 1, 1, 5, 5, 5 down here. 5 times 1 is 5. -12 plus 5, that is -7. -7 times 1 is -7. -9 plus -7 is -16. Now this does have a remainder of -16, so I know that 1 is not a 0 of this polynomial. Alright, well, that didn't work, so let's go ahead and let's do it again. I'm going to set up another synthetic division problem. 1, 4, 0, -12, -9, the same exact numbers we had before. And let's go ahead and try -1. Since +1 didn't work, let's go ahead and try our next number, which is -1. If I do synthetic division here, that'll give me 1, -1, 3, -3, -3 here. -3 times -1 is +3. 12. -12 plus 3 is going to be -9. I'll get a 9 up here and a 0. This time I do have no remainder because I got that beautiful looking 0 right there. So I know that -1 is indeed one of my zeros. I'll go ahead and just box this so I remember that that
is one of my zeros. Okay, now what I can do is, let's go ahead and take my answer here. Let's take what I'm left with, and let's keep testing whether or not we have zeros. So I'm going to set up another synthetic division problem here with 1, 3, -3, and -9. I'm reusing these numbers that I had right here on the bottom. And I'm going to go ahead and do another synthetic division problem. Let's go ahead and test. Now I could test any numbers from this whole list here. I'm going to choose, because I have the all-knowing power of what the answer already is, I'm going to go ahead and test -3. So let's go back down. Whoops. Let's go back down here. And I'm going to go ahead and test the value of -3. So there I do 1, -3, 0, 0, -3, +9, 0. Again, I was correct. There's no remainder here, so I know that -3 is also a 0. Now I'll admit, testing these zeros can be a pretty tedious process. You have to, one by one, go through your entire list here. It might be a 0, it might not. If you get the 0, you're happy because it means you get to move on. Now let me show you the reason down here that we used our answers. When we did find a 0, we used our answers to do our next synthetic division problem. Because as we keep using our answers, our polynomial gets smaller and smaller and smaller. Now once I have 3 terms here, I can go ahead and just rewrite this back in polynomial form. Remember, each of these numbers here represent part of a polynomial. This would be the constant term, this would be the x term, this would be the x squared term. If there was another number down here, it would be the x to the 4th term, x to the 5th, etc. But since we have 3 here, our 1 can be rewritten as our x squared term. That would be x squared. Then we've got plus 0x, so I can leave that out, minus 3. Minus 3. And I know we're finding zeros, so I can set that whole thing equal to 0. Now I'm just going to go ahead and solve what this is to find the rest of my zeros. So I could add 3 to both sides. That gives me x squared equals 3. Take the square root. Don't forget, when you square root, you have to plus or minus. So I'm going to get x equals plus or minus the square root of 3. And I'm going to go ahead and box that because that's a 0 as well. So going back and checking, I've got my zeros of -1, -3, and plus or minus square root of 3. So my zeros are -1, -3, and plus or minus square root of 3. So, alright, one last example, and this marathon of a video will be finished, so hang in there. We can use our new method of finding zeros to solve polynomial equations. Here we have 2x cubed plus 4x squared minus 2x equals 4. The first thing you want to do is rewrite it in decreasing order. Basically that means highest degree to lowest degree, and set it equal to 0. So I see that I have 2x to the 3rd plus 4x squared minus 2x, so that's already in order, but it's not equal to 0, so I'm going to go ahead and minus 4 both sides. That's going to give me 2x cubed plus 4x squared minus 2x minus 4 equals 0. Next, you want to make your list of possible zeros. Alright, here's my list of possible zeros. Next, I want to set up a synthetic division problem. This is going to be 2, 4, -2, -4. Next, I want to go ahead and start testing out my zeros. So I'm going to go ahead and start with +1. If I do my synthetic division, that's going to be a 2. 2 times 1 is 2. 6, 6, 4, 4, 0. What luck! We found a 0 on our first try. Alright, so we know that 1 is going to be one of our solutions, one of our zeros. So now, since we do have 3 terms left, we can go ahead and put it back as a polynomial and factor, so we don't have to keep testing our zeros because we can just go ahead and do 2x squared plus 6x plus 4. We'll set that equal to 0. Now we're going to go ahead and solve. I'm going to go ahead and factor this out. Factoring that, we get 2x plus 4x plus 1 equals 0. We can keep solving from there. If we set each factor equal to 0, we'll get x equals negative 4 divided by 2. That's going to be negative 2 and a negative 1. Now these are our remaining solutions. So overall, don't forget that 1 that we had all the way back up here. Our solutions are going to be x equals 1, negative 2, and negative 1. Alright, thank you so much everyone for hanging on for this 16-minute video, and thank you Chili for being so darn helpful. We all are greatly appreciative.